when you are teaching the tides to your students, one big problem you run into is that it's so abstract. So what we want to do is overcome that with this demonstration. We've got a bowl of water and then an object with a small amount of mass and an object with a larger amount of mass. So everything that has mass has gravity, right? So if I were to take this little trooper here and put him up near the water, he's got a little bit of mass. The water is there and it's got a little bit of mass. Therefore, they both have gravity because they both have mass, and they're pulling on each other. Now, what happens to that gravity if I pull him away from there? The gravity decreases because the distance increases. But if I bring him closer, they're pulling on each other. The water on the trooper and the trooper on the water, they're pulling on each other just like two magnets or a magnet stuck on your chalkboard. They're pulling on each other with that force, in this case of gravity. Now, what happens if I were to switch to a more massive object like this rock? What would happen to the force of gravity then, students? Well, this has more mass, therefore it has more gravity. That's right. So therefore, this is pulling on the water with more force than the little trooper was here because it's more massive. And the water's pulling back on the rock as well. So if you think of it this way, the connection of tides here, this rock is pulling up on the water. Of course, not so much you can see the water bulging up. But again, this is an abstract concept with tides, but you can imagine there is just a teensy weensy, is a little bit of pull. You'll never be able to see it or measure it, but it is pulling up.